Welcome to a special premiere episode of Math in the House. Today, we're doing Trigonometry, Chapter 1, Section 1, the measure of angles and special triangles. I'm your host, Dr. D. This is Chapter 1, Section 1 of Trigonometry. Now, the official name of the course is Math Analysis because we have a little bit more in it than just trigonometry, but we're basically going to refer to it as trig. All right, now we start trig, which is the study of triangles and the ratios of their sides, with angle measurement. First of all, an angle is an intersection of two rays. Now, a ray is a point with a line coming off it. So we have ray AB and ray AC, and their intersection makes angle BAC. Or I could call it angle CAB, or because there's no other rays attached to point A, I could simply call it angle A. Now, this O in the center of the angle here with a line through it is a Greek letter called theta. And it denotes the measure of angle BAC. Now, theta is this is a lowercase Greek letter, and in trigonometry we use a lot of Greek letters because the Greeks were really credited for coming up with a lot of the properties, theorems, postulates of trigonometry. Actually, the reason we use Greek letters is because people who don't know math and science don't use Greek letters, and so when they look at our work, it's completely mysterious to them. So we maintain an aura of superiority. Okay, so theta is the most common Greek letter. It's almost like X in algebra. Other Greek letters that we use would be alpha, which looks like a fish swimming to the left, beta, which is almost like a B, only you just have a couple of tails coming off it, and then gamma, which is the fish swimming straight down, and it's a skinnier fish. And then phi, which is the circle with a diagonal slash through it. So these are the basic Greek letters that we're going to get used to denoting angle measure. Okay, so cruising onward. Here we have a right angle, which is basically a 90-degree angle. Now, alpha and beta make up that right angle, so we would say that alpha and beta are complementary angles, which basically says that when you add the measures of those two angles up, you get 90 degrees. So any two angles that add up to 90 are called complementary. And also, here we see a straight angle, which is basically just a straight line. Now, the two angles here, theta and phi, are supplementary because their measures add up to 180. So, complementary add up to 90, supplementary add up to 180. Okay, now, let's try some really difficult problems. Okay, we have a right angle here. One of the angles is 32 degrees inside the right angle, and then we have theta, and you need to come up with the measure of theta. Okay, so theta has to be, well, basically 32 plus theta equals 90. So if you just subtract 32 from 90, you get 58 degrees. So theta is 58 degrees. 58 plus 32 is 90. They're complementary angles. All right, now here we see phi and the angle 50 degrees are supplementary angles. So what does phi have to be? It has to be 130 degrees. Right. That's it. Piece of cake. Okay, now, theta is an acute angle if and only if the measure of theta is between 0 and 90 degrees. So if I have an angle that's between 0 and 90 degrees, it's acute. And if I'm told I have an acute angle, I know that the measure has to be between 0 and 90 degrees. Likewise, theta is obtuse if and only if theta is between 90 and 180. And so likewise, if I know that I have an angle between 90 and 180, then I have an obtuse angle. So acute, small. Obtuse is big. Okay, so that's it. Now next we're going to be talking about angle measurement. Now most people know about the degree, but we also have fractions of a degree, and we call them minutes. So 1 degree equals 60 minutes. And 1 minute equals 60 seconds. Now notice the mark for degree is the little 0 superscript. The mark for minutes is the same as for feet. You just put a little single notch up there. And then the mark for seconds is 2 notches, just like inches. Now, you can think of a degree just like an hour. There's 60 minutes in an hour, there's 60 minutes in a degree. And likewise, 60 seconds in a minute. So, if we have the angle 23.76 degrees, now we want to convert that to degrees, minutes, seconds, or what we call in the biz, DMS. Okay, so first thing we do is we register the fact that we have 23 degrees. So 23 degrees goes right there. Now we have 0.76 degrees, and we want to change that into minutes. So what I do is I go 0.76 degrees over 1 times. Now, this is called unit analysis. What I'm trying to do is cancel the degrees. Well, to cancel the degrees, I put degrees on the bottom because if it's on the top and the bottom, they cancel. Now I want to put minutes on top. And now this tells me, should I multiply or divide by 60? Well, is there 1 degree in 60, or 1 minute in 60 degrees? Or is it 60 minutes in 1 degree? And that's right, 60 minutes, 1 degree. So now when I multiply across, I have 0.76 times 60. So 0.76 times 60 is 45.6. So 45.6, and what do I have? Well, the degrees cancel, so I have 45.6 minutes. So that means I have 45 minutes. Now I take what's left is the 0.6 second, or 0.6 minutes, and I need to convert that to seconds. So I do the same thing again. I say I want to get rid of minutes, so I put minutes on the bottom and put seconds on the top. There are 60 seconds in 1 minute, and so when I multiply 0.6 times 60, I have 36. And what are the units? The minutes, the minutes canceled, and I'm left with seconds. So I have 36 seconds. That's it, game over. Okay, so all you do is put your degrees down, take your decimal, multiply by 60, and you have minutes. Multiply that by 60, and you have seconds. Now, let's go the other direction. I have 72 degrees, 12 minutes, 27 seconds, and I want a decimal of degrees. So clearly, I have 72 point something degrees. Now, 12 minutes. So what I do is I go 12 minutes over 1 times. Now this time I'm trying to get rid of minutes and trying to turn it into degrees. And I know there's 1 degree in 60 minutes. So when I go 12 divided by 60, then I end up with 1/5 or 0.2 degrees. Now, I have 27 seconds over 1 times, now I'm trying to get rid of seconds, so I put it on the bottom, and then I put minutes on the top. There are 60 seconds in 1 minute. Well, now I have minutes, but I don't want minutes, I want degrees. So I have to put minutes on the bottom again and degrees on the top. There are 60 minutes in 1 degree. So notice basically I'm dividing 27 by 3600. Now the minutes cancel, the seconds cancel, the minutes cancel, and I'm left with degrees. So 27 divided by 3600 is 0.0075. degrees. Now what I do is I add 0.2 with 0.0075. So notice it's 0.2000 and plus 0.75, oops, rats. Plus 0.0075. So notice what I end up with is 0.2075. So that's the fraction of degrees that I have. So I have 2075 degrees. So bottom line is each degree is a whole degree. Each minute is a 60th of a degree, and each second is a 3600th of a degree. So you just add up those fractions and put it on the number. Okay, so cruising onward. Next we have a thing we call coterminal angles. Now, coterminal angles are any two angles that are 360 n degrees apart, where n is any integer. So that basically means two angles with the same position, but there's some number of full circles difference in degree measure. So what does that mean? All right, let's say we have this angle 40 degrees. Okay, so theta is 40 degrees. Now if I want the coterminal angle to that, then that means I could just add 360. So theta could also equal 360 plus 40 would be 400 degrees. Now if I add 360 again, then I have theta equals 760. And I could just keep adding 360, and I keep getting coterminal angles. So 40, 400, 760 are all coterminal angles because they are all 360 degrees n apart. So 40 and 400 are 360 degrees apart. 40 and 760 are 360 times 2 degrees apart. And they're basically in the same position, but the 400 has just spun around one more time, and the 760 has spun around 2 more times. So these are coterminal angles. Now, an angle is made up of an initial side and a terminal side, or beginning and end. And it travels in a particular direction. In this case, we're traveling counterclockwise, which is the positive direction. Now, what if my angle starts with the initial side and it goes all the way around to here? So now here's my initial side, here's my terminal side. Well, a straight angle, remember, is 180. And this is, let's say, 40 degrees past 180. So 40 degrees past 180 would be 220. Now, I could also call this 360 added onto this would be 580. So 220 and 580 are coterminal angles. So anytime I want another coterminal angle, all I do is add or subtract some number of 360s. Okay, now we have this angle that goes all the way around, almost all the way around 360, but not quite. So notice it's, let's say, 30 degrees short of 360. That would mean theta equals 330. Okay, that's 30 degrees. If it went 30 more degrees, it would be at 360, which would be back to where it started. Now, if I add 360 to this, then I would get 690. And if I added 360 again, I would end up with 1050. So all these are coterminal angles describing this one position. So the angles are in the same position, but their degree measures are different because they are coterminal angles. In other words, they're 360 degrees apart. Okay. Now, like we said, the clockwise direction is positive. The counterclockwise direction is negative degree measure. So this looks like the same angle that we had in the slide before, where it starts here and goes up to here. That's a positive angle. But this time what's going on is, instead of measuring clockwise, we're going to measure, or instead of measuring counterclockwise, we're going to measure clockwise. So what does this mean? Well, this means I'm going negative degrees this way. Now, if I go all the way out to here, that's 180. And then I'm going another, basically, let's say 40 degrees short of 360. So that would make it negative 320. And if I kept going 40 more degrees, then I would get to negative 360, which would be one time around in the clockwise direction. Now, I could also say that theta equals, add 360 to that, and you get 40 degrees. So 40 and negative 320 are coterminal angles. But it just means which direction did we go. If we went clockwise, it would be 40 degrees. If we go counterclockwise, it becomes negative 320. Same thing here. If I go clockwise, or I'm sorry, counterclockwise, then I end up with 180 plus 40 is 220. But instead, I'm going now clockwise, so it's about 40 degrees short of 180, so that would make it 140. Negative 140. Keep forgetting the negative. Negative 140. Now, if I went Counterclockwise, like I said before, now I would have theta equals 220. And when you add 140 and 220, you get 360. Now, here's the one that we said before. We went all the way around and we're 30 degrees short of 360, so that was 330. Well, now, instead of going around counterclockwise in the positive direction, I'm going clockwise in the negative direction, so this just becomes negative 30 degrees. So if I add 360 to that, then I could have theta equals 330. So 330 and negative 30 are coterminal angles. Okay, so that's basically it. Since we went the negative direction, then, or since we went the clockwise direction, all these angles are negative. All right, now, the last thing we're going to talk about is special triangles. So we've got two very special triangles. We've got 45, 45, 90 and 30, 60, 90 right triangles. Now, in any right triangle, we have two legs and a hypotenuse. Two legs, hypotenuse. The legs are 90 degrees from each other, and the hypotenuse is the longest side that connects the legs. Now, with the 45, 45, 90, we have a special ratio of sides. So each leg is going to be 1 to 1, and the hypotenuse is going to be the square root of 2. Because the Pythagorean theorem says that a squared plus b squared equals c squared. So that means 1 squared plus 1 squared equals 2. And when you square the square root of 2, you get 2. So 1 to 1 to square root of 2. Now, this doesn't mean every 45, 45, 90 right triangle has one, the leg is 1, the other leg is 1, the hypotenuse is square root of 2. But their ratios are 1 to 1 to square root of 2. Now, with the 30, 60, 90, the short leg we're going to call 1. The hypotenuse is always twice the length of the short leg. So we're going to call that 2. And the long leg is always the square root of 3 times the short leg. Okay, so now, this is something really important that you memorize. That the 45, 40, 90 is 1 to 1 to square root of 2, and the 30, 60, 90 is short sides 1, long leg is square root of 3, and hypotenuse 2. All right, so let's try some example problems. The legs of a 45, 45, 90 triangle are 6 feet. Find the length of the hypotenuse. Okay, so our 45, 45, 90 looked like this. So we know the legs are 6 feet, and we need the length of the hypotenuse. So what we can do is say if this is 1 to 1 to square root of 2, then all we do is say the hypotenuse is going to equal 6 times square root of 2. That's it every single time. Just multiply the side by square root of 2 and you get the hypotenuse. Now, if we wanted to do it the old-fashioned way with the Pythagorean theorem, we could say that h squared equals 6 squared plus 6 squared. So that means h squared equals 36 plus 36 is 72, and that means h equals the square root of 72. But we are not like the godless heathen who leave perfect squares under the radical. So square root of 72 is 2 times, or 72 equals 2 times 36, which is 2 times 2 times 3 times 3. So there's our 72, 8 times 9. Now, 2 of the 2's band together and spring the pokey. And 2 of the 3's band together and spring the pokey. And so we end up with 2 times 3 on the outside, which is 6 times square root of 2. But look how much quicker we got 6 square root of 2 here, because all we did was just take one length of the leg multiplied by the square root of 2, and we're done. So the length of the hypotenuse is 6 square root of 2 feet. That's it, game over. Okay, what about if the short leg of a 30, 60, 90 triangle is 2 centimeters? So this triangle is in France, of course. Okay, so we need the lengths of the other 2 sides. All right, so let's draw our triangle. So we draw our 30, 60, 90 right triangle, and you want to try to draw your 30, 60, 90 to scale so that you can tell the difference between the short side and the long side. So the short side is 2 centimeters. Now, the hypotenuse is always twice the short side, so that makes it 4 centimeters. And the long leg is always the square root of 3 times the short side, so this becomes 2 square root of 3 centimeters. That's it, game over. Okay, now, what if we're given that the hypotenuse of a 45, 45, 90 triangle is 10 miles, and we need to find the length of the legs? So we draw our 45, 45, 90 triangle. Okay, so the hypotenuse is 10 miles. Now, what is the length of the legs? Well, if I multiply the leg times square root of 2 to get the hypotenuse, then all I do is divide by the square root of 2 to get the legs. So the legs are going to be 10 divided by square root of 2. Now, here's the thing. We are not like the godless heathen who leave radicals in the denominator either. So we need to multiply by square root of 2 over square root of 2, and I end up with 10 square root of 2 over 2, which equals 5 square root of 2. And now both legs are the same length, so the length of the legs are 5 square root of 2 miles. That's it, game over. Okay, and one last problem. We have the hypotenuse of our 30, 60, 90 is 10 furlongs. So, what are the lengths of the other 2 legs? Well, I know the short leg is going to be half of the hypotenuse. So that's 5. And I know the long leg is going to be the square root of 3 times the short leg. So that's 5 square root of 3. So the length of the other 2 legs are 5 furlongs and 5 square root of 3 furlongs. So that's it. Have fun with these.